All right, this video we're going to talk about naming. So we're going to name our alkenes and cycloalkenes. One note is the chapter does talk about common names, and it's worth reading through that section, but you are not going to be responsible for memorizing those names. So here's our rules. We'll walk through the rules and then do a number of examples. So the first rule is instead of ane that we had with our alkanes, now we're going to end in ene because we're going to have a double bond or more. Your parent carbon chain, which is your longest chain, just like it was for alkanes. This time you need to make sure your longest chain contains the double bond. So if you've got branching going on, make sure the double bond is in the longest chain that you're counting. Then when you number, you need to number to give the double bond the smallest number possible. So for alkanes, we had to give the substituent the lowest number possible, or the group coming off of the chain. Here, the key is the double bond needs to have the lowest number possible. So in the example shown here, we number from left to right. The first time a number lands on the double bond, it gives it number 2. If I were to number the other direction, the first time we number the double bond is 4. So we do want to start, in this case, on the left, so that the number 2 is the number for the double bond. Next rule is the double bond is going to be indicated in the name with its number. So here our longest chain is 6, so that's the hex. It ends in ene because there's a double bond. That double bond starts on carbon number 2, so we have to have that 2 somewhere in the name. Then you're going to put in your prefixes just like you did before. In this case, I have a methyl group on carbon number 2, so 2-methyl. So 2-methyl-2-hexene would be the name for this structure. If you have 2 or more double bonds in your ring, you're going to end the name with diene or triene. So diene is 2 carbon double bonds, triene would be 3. You would also use numbers to indicate the location of both of the double bonds, just like you did when there was a single double bond. When you are naming rings, your cycloalkenes, if there's no group on the ring, you don't need to number the ring. That's because the double bond is going to just assume to be carbon 1. If you have a group on your ring, then you're going to number so that the double bond is always 1, 2. Now the direction you number, whether it's clockwise or counterclockwise, is going to depend on where the groups are. So you're going to want to give the groups the lowest number possible in those cases. So in this first example, there are no groups, so it is just going to be cyclopropene. In the second example, we're going to give the double bond numbers 1 and 2. I give the top carbon number 1 because that's where the group is. So this is going to be 1-methyl cyclopropene. Now you could put the 1 in here if you want, but it's not absolutely necessary. For the second, 1, 2, and then that puts the methyl on 3. If I go clockwise, if I went the other way, 1, 2 for the double bond, the methyl would be numbered 4, which is higher than 3-methyl. So we're going to use the clockwise numbering. Get rid of my extra numbers here. So we have 3-methyl cyclopropene. Again, we know the double bond starts on number 1, so you don't have to have a 1 in the name. If you have more than one double bond in a ring, one double bond is always going to be numbered 1, 2, and then the second double bond gets whichever number it is, as long as it's the lowest number possible. So here we will use the 1 to say that where the first double bond is, and then in this case the second double bond is on carbon number 4. So 1, 4 cyclohex because there's 6 carbons, and then diene because there's 2 double bonds. So let's try some. So the first example on the left here, we have a total of 1, 2, 3, 4, 5 carbons. So if I number left to right, carbon number 1 is the double bond. If I number from right to left, my double bond becomes number 4. So I'm going to use the left to right numbering system in this case. I have no groups, so this is just going to be 1 pent for 5, and then ene because there's a double bond. Second example here is a cyclo structure. So the double bond is always going to be 1, 2, or if I go the other direction, 1, 2. So I'm going to finish this off, do 3, 4, 5, and 6. If I finish my red numbers, I've got 3, 4, 5, and 6. So we're going to figure out which one's better based on where the groups are. So if I look at my red numbers, I have a group on number 2 and number 4. If I look at the blue numbers, my groups are on number 1 and number 5. So the first time we come to a different number, which in this case is the first number, the lower number wins. So the blue numbering system is the one we're going to use. So we are going to have an ethyl group on number 1 and a chloral group on number 5. We still alphabetize our groups, so C comes before E. So we're going to have 5 chloro, 1 ethyl, cyclo. Here we've got 6 carbons, so it's hex, and then ene. All right, go ahead and pause the video and see if you can name these structures. And actually, now that I'm looking at them, these structures are identical. So just try to name the one. All right, so to name this structure, we can number from left to right or right to left. With the red numbers, I get a double bond on number 2. With the blue numbers, I also get a double bond on number 2. So when there's a tie, you break the tie with the group number being the lowest. So for the blue, the number for the methyl group is also 2. For the red, the number for the methyl group is 3. So again, blue wins. So we're going to put the methyl group, we've got 2 methyl. And then the double bond is also on carbon 2. 4 carbons is bute. And then ene for the double bond. All right, here's a couple more examples. Again, work through these, pause the video, see if you can come up with answers on your own, and then come back and check them. All right, this first example, number right to left, or left to right. So red numbers, we've got 3 for the double bond. Blue numbers, we have 2, so blue wins. So we've got 2, 5 carbons is pent, double bond, ene, put an extra E in there. So pentene. Next structure, you can number both directions. Red number, double bond is on 3. Blue numbers, double bond is on 2. So blue wins. We also have a methyl group, which is on number 3 in this case. So we have 3 methyl, 2, 4 carbons is butene. Last example, we have a ring. So the numbers for the double bond are always 1, 2. So if I check both directions, I'm going to break the tie with the lowest number for the group. So for blue, the group is on number 2. For red, the group is on number 1. So red wins. So we've got 1 methyl, cyclo. In this case, 5 carbons is pent, and then ene for the ending. Here's a few more examples. Go ahead and pause the video and work through these. What you have is a name that is incorrect. So draw a structure with the name, then look at the name and try to figure out what the look at the structure and try to figure out what the correct name should be. When doing this, basically forget what name it gave you after you have the structure drawn. Let's look at the first example first before you pause so you have an idea of what you're going to do. So 2-ethyl, 2-pentene. So 5 carbons is pent. I'm going to make up my number direction. It says the double bond is starting on number 2, so it's right there. And then there's an ethyl group also on carbon number 2. So now I'm going to pretend that this name doesn't exist. I know it has to be wrong. And I'm going to look at my structure and just decide how I'm going to name this. So the chain that I originally had going across was 5 carbons. But always remember you need to find your longest chain. If I go down this group, now I have 6. So 1, 2, 3, 4, 5, 6. So that was the problem with this original name, was the longest chain wasn't used. So now I've got 1 through 6 going left to right. I'm also going to check the other direction. So with green, I have the double bond on number 3. With blue, I also have the double bond on number 3. So I do have this methyl group, which in blue is on number 3, and on green is on number 4. So blue wins. So I've got 3 methyl, 3, actually I have 6 carbons is my longest, and then ene. So 3 methyl, 3 hexene. So now go ahead and pause and see if you can do numbers 2 and 3. All right, if I draw number 2 out like it's named, I have hexene. So 6. It says the double bond is starting on number 4. So there's the double bond. I have a methyl group on number 4 and a methyl group on number 5. So that's what the name says I have. Again, I'm going to ignore it for now. And if I look, my longest chain is the 6 that I started with. I already have my numbers left to right. Let's try numbering right to left. So notice with the red numbering system, my double bond starts on number 2, whereas with the blue, it started on number 4. So my numbers were wrong in the original name. So with the correct numbering system, now my methyl groups are on carbons 2 and 3. So I've got 2, 3 dimethyl. Double bond is on number 2, and then hexene. For the last example, I have a cyclohexene. I'm going to put my double bond in, which I know needs to be 1 and 2. This says I have a methyl group on 1 and 2. Oh, excuse me. So it says my methyl group's 1, 2, but then the double bond is on number 4. So my double bond's not here. It's actually going to be here, because this is 3 and this is 4. So now I've actually already pointed out what the problem is. The double bond has to be 1, 2. So the numbering here has to give 1, 2 on the double bond. So I could go this way, or I could go the other direction. If I look at the purple numbers, my methyl is on 4 and 5. If I look at the blue numbers, my methyl is also on 4 and 5. So it doesn't matter. So I'm going to have 4,5 dimethyl cyclohexene. Remember that double bond always has to be 1. All right, in the next video, we're going to talk about drawing these structures using line angle formulas.